Hello, everyone. I'm excited to be presenting today on bioinformatics pipelines through the ages, from Bash to workflows to agents. My name is Ken Brewer. I am the Scientific Solutions Lead at Seqera. And the content of my slides today were developed in collaboration with a lot of Seqera's scientific development team, especially the people here on the right. And I wanted to present this a bit as a retrospective of how I've seen bioinformatics evolve, both in the industry and in my own personal journey as a bioinformatician. And I think kind of some of the trends that I'll talk about today happen at different time scales and in different people's own journeys and in projects and in teams. And the way that I've organized it is organizing things into 4 ages, beginning with the dark age of bioinformatics, of using fully manual execution for all of the things that you're working on. Next, I have the industrial age, where you've got more mature tooling, especially Nextflow for organizing and managing the computational analyses that you're working on. Then there's the modern age of bioinformatics, where you're using integrated platforms, especially Seqera platform, to offload a lot of the complexity of working within a team and an organization. And finally, something that we're just at the beginning of, but is very exciting, is the agentic age, when we've got powerful new tooling built off of the powerful large language models that can really accelerate and improve the way that your workflows and processes as a team are happening. So diving into kind of how this evolution happens, let's go back to the beginning with the dark age of bioinformatics, of a fully manual execution. And I called this age the dark age, both because it's less advanced in terms of the tooling that you're using, and also because often you find yourself a bit in the dark anytime you try to figure what went wrong with the analyses that you're working on. And for the dark age of bioinformatics, I think this is really defined by having essentially either fully manual execution or handcrafted artisanal bash scripts that are using locally installed software versions. And typically you've got some amount of human involvement in every step of the process. And so if you look at the typical type of analysis that a bioinformatician might want to do on the right, where I've got a whole genome sequencing analysis kind of mapped out, from the sequencer writing data to a hard drive, which may or may not need to get shipped to a cloud or a cluster, and then going through some amount of pre-processing, alignment, variant calling, before finally doing interpretation. For this type of typical bioinformatics workflow, you might have some 15 different software tools that are all required, up to 130 different command executions. And essentially, you're completing a research odyssey for every computational project. And this is how it was done when people were first figuring out how to do whole genome sequencing and variant calling to figure out clinical diagnostics from a genomics perspective. Now, there are, of course, a lot of places where this can go wrong. All of times, things are not very traceable. You're not using Git versioning. You've got limited logging. Things aren't super reproducible. You're not using software containers. You've got peak, it runs on my machine syndrome. And things are also often not scalable. A lot of times you've got reliance on hard-coded paths, both for your data and for your infrastructure, what makes it very challenging when you try to shift to a new project or try to increase the amount of data that you're flowing through your processes. And I think Nextflow is really a response to these challenges that were just kind of overwhelming the genomics field. And it's a really elegant solution to addressing these problems in an integrated package. And that kind of brings us to the industrial age of bioinformatics, which is defined by adopting more modern software tooling, especially as it comes, especially Nextflow. Now, for the industrial age of bioinformatics with Nextflow, you're using containerization of your tools for reproducibility. You've got the ability to set up standardized reusable workflow definitions. And Nextflow handles resuming and error handling to give you incremental execution. And Nextflow tackles one of the most complex parts of this overall process, kind of the pre-processing through variant calling part, very elegantly. And instead of having 15 different pieces of software and 120 plus command executions, you've got a single unified command line interface that can run the analysis from beginning to end with traceability, portability, and scalability throughout. Now, there are still challenges that you encounter while working in the industrial age. You'll have lost data sets and configurations. It's easy to lose track of which pipelines you've run and what data is associated with them. There's also a lot of challenges that you face while collaborating within or across teams. Let's say you want to give a wet lab scientist access to running the pipelines on their data themselves. Now you need to set them up on a cluster or a cloud environment and teach them how to interact with a Linux CLI. And so it's very challenging to onboard less computational people into being self-sufficient for their analyses. And then there's also a lot of difficulty that you encounter just in managing the infrastructure for running your jobs, and also any integrations that you need to build around triggering certain tasks on completion of a workflow. And Seqera platform really solves these challenges quite elegantly by providing a unified platform for teams to collaborate and configure, monitor, and scale their analyses. And that takes us into what I'm calling the modern age of bioinformatics. And in the modern age of bioinformatics, I think this is defined by teams recognizing that rather than needing to build everything in-house and roll their own for all of the different tooling that they need for working with Nextflow, they instead can shift that undifferentiated heavy lifting onto a modern high-quality platform such as Seqera, and instead focused just on their science and get everything that they need for scaling their analyses in a single place. And Seqera platform provides that quite elegantly by giving you a way to abstract your infrastructure and save the configurations for working with your Nextflow pipelines. It unifies your data, your compute, and your containers, no matter what type of stack you're using, and bring it together into workspaces with strong organizational guardrails so it's much easier to collaborate. And you also get container augmentation for optimized cloud data usage. And this is primarily done through Fusion and gives you the ability to decrease the cost of your analyses quite well. And once you have Seqera platform as a tooling to work with, you get additional support across this research odyssey, like into triggering the jobs automatically based off of the data being deposited in a certain bucket, and all the way through the interpretation where you have studios that can spin up interactive analysis environments of ways of browsing the data interactively. And I think Seqera also is strongest because it gives you this seamless journey from development to production. You're typically iterating on your pipelines in Nextflow. And when you have Seqera platform, there is not much that's needed in terms of promoting that new development version of your pipeline all the way into production. And you've got CI/CD pipelines and everything that can support you in making sure that that is robust and scalable. One thing to be aware of that we want to make sure that everyone knows is that we have a new Seqera platform free tier available. So if you sign up with Seqera platform, with an organizational email address, you can get a workspace set up with compute credits that you can use to explore. So be sure to check it out if you haven't tried the tooling out already. Now, when you're working with Seqera platform, not everything is going to be sunshine and roses. The things that we see at Seqera and working with our customers is that a lot of times you'll have difficulty with the troubleshooting of jobs. Even though we're exposing a lot of the logs, Figuring out kind of exactly what needs to be done to fix problems can sometimes involve deep and broad knowledge of the tooling that you're working with. You've also got multiple layers of configuration that are being applied to a pipeline run, from both the organizational and compute environment levels to the configuration coming from the pipeline itself. And that can really increase the complexity involved of the investigations that you do. And finally, when you're adding new functionality to complex workflows, it can be really challenging to just know, like, where do you inject a new set of processes into a complex workflow. And I think Seqera AI and conversational AI tooling and model context protocol servers really are a game changer in that they provide this context and knowledge to much more rapidly iterate on the systems and codes that you have deployed in Seqera platform. So that takes us into the agentic age of bioinformatics, which is defined by conversational AI tooling and model context protocol servers. And we're just at the cusp of this age. But I think we're starting to see just how impactful this new tooling can be for bioinformatics. When you're working with Seqera AI and our MCP servers, you've got natural language interaction with your platform and your workflows. You've got the ability to integrate multiple different systems using your MCP servers, so you can query stuff both about your infrastructure and your code. And the place where I really see it kind of working in terms of how it changes how your team works is that you've got this improved debugging from your context from the logs and the config. You've got the ability to have like version controlled pipeline code suggestions that can give you faster solutions to your needs and problems. And I think this really results in allowing you to make faster iterations on your code, your data, and your infrastructure. And I've represented that in the diagram on the right with these new dotted lines showing how from the analyses that you do, you can make changes to your cloud infrastructure, your pipeline, or kind of the scientific workflows themselves and analyses that you're doing. I think AI and LLM tooling can be really impactful in terms of allowing you to iterate on these overall processes much more quickly. So we've got a couple of examples of using Seqera AI to do some of these that me and some of my other SciDev team members have put together. Here's an example of me asking, hey, I have this pipeline that is stalled. Can you tell me what is wrong? And Seqera AI goes and sees that it's stuck in a running state, figures out that it has stalled due to resource allocation issues, that there's a particular task that is requesting too much CPU and memory, and it's able to go ahead and relaunch that pipeline with new resource limits applied that allows it to complete successfully. I think this is a great example of how Seqera AI can help troubleshoot pipelines failing due to infrastructure problems. Here's another example. Here, one of my teammates has asked Seqera AI to add a new tool after our variant calling to filter any of the annotated variants using a filter. And Seqera AI successfully figures out how to apply BCF tools with the appropriate configuration that's needed to apply a quality filter. And it creates a pull request on the GitHub repo with the set of changes that it would like to suggest. And of course, we have both Seqera AI, which is available on our website, but we also have a model context protocol, which allows you to work with any of your AI tooling of choice, whether it's Claude, Cursor, GitHub Copilot, Seqera AI, and with the MCP server, you can get all of the information that you need in order to do the deep integrations that you customize and set up yourself. So as a final thing, a little bit of a retrospective in terms of why I think Seqera AI is very well positioned for this new era of bioinformatics. I think throughout the industry, you're going to see some version of this AI sparkle show up in a lot of different tools. But many times, I think you'll find that other bioinformatics AI agents will kind of revert back to the dark age of bioinformatics, where they're calling commands custom one at a time rather than using best practice tooling throughout. And when you're working with Seqera, you are building on a foundation of Nextflow, multi-QC, Fusion, Wave, and Platform, and having Seqera AI being able to implement solutions based off of this high-quality foundational tooling, I think will be very impactful for how effective it's going to be in iterating on your pipelines. So thank you so much, and I am happy to take any questions at this time.